right, so let's review ellipses. So an ellipse is like an oval. It can open, it can be stretched to look more vertical or more horizontal. And so one of the first things I just want to refresh your memory on is that in order to tell if it's going to be vertical or horizontal is to look at the denominators of the two fractions. Whichever fraction has the larger denominator, that will tell you if it's going to be vertical or horizontal. So this one is a vertical ellipse because the larger denominator is under the y. This one is a horizontal because the larger denominator is under x. So that's going to help you identify what your a and b variables are. Your a and b variables will tell you, are kind of like your two radii, if you will. If it's a horizontal, your a is your horizontal vertex or radius. So you're going to go from your center, right and left 6, and then we would go up and down 2 to get our 4 points that we would connect into that oval shape. Again, we get the circle from the numerators just like we did with our center or our circle, right? We get our center from the values that we're squaring. So nothing, zeros being added or subtracted with x, and then positive 2 here, always taking the opposite sign. So we get our center, we get our a radius, we get our b radius, and then we connect the dots. So that can all come just from looking at the equation in standard form. After that, we take a and b, and we use this equation a squared minus b squared equals c squared to figure out what c equals. Remember, c is the distance that we're going to move to get to the two foci. The foci are always on that major axis. So in this case, if it's a horizontal, the major axis is this dotted green line. So when we solve the equation for c, we get that c is the square root of 32, which comes out to be about 5.7. So to plot our foci, we're going to start at the center and go right and left 5.7. Since we started at the center and then moved horizontally, it's the x value of our center that's changing. So when we write the coordinates of our foci, we're going to take the center and we're going to add and subtract that plus or minus square root of 32, which reduces to the plus or minus 4 root 2. We get that because 32 is 16 times 2. So the square root of 16 is 4, and then the square root of 2. I'm fine if you write it with the radical or the reduced, or even the decimal, I guess is fine. But we're taking 0 and we're going left and right. So plus and minus the 4 root 2, where the y value is staying the same. Okay, and then again, the major axis and the minor axis are dependent upon whether it's horizontal or vertical. So since this is a horizontal, because a is under x, our major axis is 2 times 6, because we went 6 and 6, and then the minor axis up and down 2. Okay, so that's a straightforward explanation for how to graph and give those characteristics if the equation's in standard form. Meaning for an ellipse, it has to equal 1. So if it doesn't, make sure you divide every single term on both sides so it does. And so it's this number. So if we look at this example here, number 5, it's this 225 is what we have to divide every single term by in order to get it in standard form. So when we divide by 225, 9 divided by 225, and you can use your calculator to help you with this. So if we do 9 divided by 225, you can turn that math, enter, turn it into a fraction. That's how we get the 1 over 25 here. And then if we do 25 divided by 225 and turn it back into a fraction, that's how we get the 1/9, 1 over 9. So to turn our equations into standard form for an ellipse, we're going to divide every single term by whatever this is on the equal sign. Now, hopefully what you saw with number 6 is that when we divided everything by 36, these two coefficients were the same. So when we simplified, both a and b are the same. So we don't have two different radii, we have the same radius in all directions. And so when that happens, when these denominators are the same, this is actually a circle. And so what we can do is instead of dividing by 36, we divide everything by 9, and that's where we get 36 divided by 9 is 4. We get that our The radius squared, 2 squared is 4. And so make sure you know how to identify an ellipse versus a circle. That's one of the things will be assessed on the quiz today and what we practiced here. So quick review, our parabolas are always going to have both x and y will not be squared. Only one of them will be squared for all of the parabolas. So if it's going to open up or down, it's going to be y equals, if it opens up or down, and then x squared. To open left or right, it'll be x equals, like a horizontal parabola, y squared. So only one of them will be squared. A circle is going to have the same coefficients or just one single radius. An ellipse will have those fractions equaling 1. However, it might not always be in standard form. So like for number 18, you'd have to divide and see, do those coefficients or are these coefficients the same? Since they're not, we know that this, if you were to convert it to standard form, they have the two different denominators. So this is in fact an ellipse versus something like number 11, very similar, right? Setup, but this time these two coefficients are the same. So this is a circle. If we were to divide everything by 20, these two denominators would be the same. So we know it's a circle. Okay. Awesome. So then the last thing just wanted to go over quickly is what if we have an x squared and an x term or a y squared and a y term? Well, then we have to complete the square in order to find all those out. And so we can just do we can do this one right here, number 5, really quickly. So first thing we're going to do is organize, right? I'm going to get all my x's together. So I have 9x squared and the negative 18x. I'm going to put those together. And then I'm going to get my y squared and my negative 6y and put those together, right? Just rearranging. And then always bring that constant to the other side. So notice we have the positive 7 here. After we do that, if there's a coefficient for our x squared, we have to factor it out. So the x's have this 9 coefficient that we have to factor out. So I'm going to factor it out. 9x squared divided by 9 is x squared. Negative 18x divided by 9 is negative 2x. And then I leave this blank space to complete the square. But I'm also going to put a blank space on the right-hand side to make sure I balance out when I complete the square. So to complete the square, I divide negative 2 by 2, square it, and get positive 1. When I write the 1 here, I'm not just adding 1 to the left-hand side of the equation because it's in these parentheses that are being multiplied by 9. So I do this bounce pass over to the other side of the equation. 9 times 1 is 9. I really added 9 to the left-hand side, so I have to make sure I add 9 to the right-hand side. And that's because the x squared had this coefficient that I had to factor out and deal with. The y's, on the other hand, didn't have a coefficient. It was just 1y squared, so we could just complete the square as normal. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So when I add the 9 here, I just add it to this side as well. So now this guy is a perfect square trinomial that I can factor, and this guy is a perfect square trinomial that I can factor. Don't forget to bring your GCF down, okay? And 7 plus 9 plus 9 is 25. So we get this nicely simplified equation, but now I have to convert it to the standard form for an ellipse. So I'm going to divide everything by the 25. 9 divided by 25, remember, this one does not simplify, right? If we were to use our calculator and do 9 divided by 25 and turn it into a fraction, we get 9 divided by 25, right? It doesn't simplify to 1 over something. And so the trick we talked about last week was when that happens, you just write it as the reciprocal. Instead of 9 over 25, write 25 ninths as the reciprocal in the denominator, and that will help you write it in standard form. So then from here, 25 is the larger denominator. So this is a vertical ellipse with a center at 1, 3. So we have our center at 1, 3. We can do the a squared minus b squared equals c squared and get this value for our c. And because it's vertical, we're going to be moving vertically to get to our foci. So it's that y value that will change. So we just take the center as is and we just add and subtract the c value to get the foci location. And we answer the question. All right, so I hope that makes sense. This is more of the same. Again, when the squared term have the same, that's a circle. When the squared terms have different coefficients, that's an ellipse. And when there's only one square term, those are parabolas. And you can determine if they're horizontal or vertical from there. All right, guys, I hope that helps. I know you're going to do great. Go rock it. I'll see you on the other side.